friends, how are you? I am Teach Guru. Subscribe my channel, like my channel. So today I am going to teach you about the combustion of the alkanes. Today I am going to teach you about the combustion of the alkanes. What do you mean by combustion? Combustion means addition with oxygen and reacting with something. See friends. Alkane. Alkane combustion. Alkanes combustion. Today we are going to learn about the combustion of the alkanes. There are two types of combustion in the alkane. One is in the sufficient supply of oxygen and another is in the insufficient supply of oxygen. Sufficient supply of oxygen is only the most favorable reaction, but insufficient supply of oxygen is not favorable because it produces some dangerous gases which are harmful for the atmosphere and causes global warming. So today we are going to see the combustion of the alkane in two conditions. One is insufficient supply of oxygen and another is insufficient supply of oxygen. So first we are going to learn the sufficient supply. First we are going to learn in the sufficient supply of oxygen. Sufficient supply of O2. Where is the oxygen? Okay. Before I told you that methane is the first compound of the alkanes group. So methane is only taken for all the reactions. And here I will show you about two alkanes. There is methane and ethane. The first methane that I write in this formula was what? This formula was CH4 plus O2 and gives out C friends. Any alkane plus oxygen will form their carbon dioxide and water in only sufficient supply. During sufficient supply of O2, any alkane reacting with oxygen will give out carbon dioxide and water. So let us write CO2 plus H2O. So CO2 plus H2O finished. Here H is 4, so you have to put 2. Oxygen also becomes 4, then you have to put 2. So you finished. This one is for methane. This one is for methane. This one is methane. This one is for methane. Now I am going to show you the second alkane, that is ethane, that is C2H6. The formula of ethane is C2H6. So see, same reaction will there. C2H6 also will form CO2 and H2O. Okay. All the alkanes only in all the alkanes when they will react with oxygen, they will give out carbon dioxide and water. So here CO2 plus H2O. See, there is one way of balancing this one. There is one way of balancing this one. you have to put 2 in front of carbons always. So by seeing that, you have to do the rest of the equation of the balance. But except in the sufficient supply the methane, except the sufficient supply the methane reaction, you have not put 2 in front of the carbons. And rest all you have to put 2 at the first only. See 2 you put here. See 2 you put. So this one becomes first. Carbon becomes 4. So here will be 4. The carbon becomes 4. There is also 4. Hydrogen is 12. Here hydrogen is 2. So 6. See hydrogen also becomes 12. Now oxygen you see here the oxygen is 4 to 8 and 6 is 10 oxygen. So here will be 5. See friends, 2C2H6 plus 5O2 gives out 4CO2 plus 6H2O. Okay, this one is the sufficient supply of oxygen. So you see first. This one is in the sufficient supply of oxygen. Okay, now let us learn about the insufficient supply of oxygen. Insufficient supply of O2. But insufficient supply of O2 is not a good reaction, because in the insufficient supply of O2, the product form is very dangerous for our environment and causes global warming. Product here form is CH4 plus O2. Here will form methane. Here will form carbon monoxide. It is CO. CO plus H2O. See friends, any alkane reacting with oxygen in the insufficient supply will give out carbon monoxide and water. So one more time I am telling, any alkane reacting with oxygen in the insufficient supply will give out carbon monoxide and water. So similarly, C2H6 plus O2 will also give out CO plus H2O. See friends, what I told you, first only to balance this equation, first only we have to put 2 here. So put 2. See friends, I told you have to put 2 in all equations. In first only, in front of the alkane you have to put 2. Except the methane's reaction in the sufficient supply of oxygen. Except the methane's reaction in sufficient supply of oxygen. See now. See here 2 carbons, here 1 carbon. So here you put on 2 carbon. Finished. Yeah. Hydrogen is 4 into 2, 8. Here hydrogen is 2. So put here 4. And finished. Here oxygen is 2. Here oxygen is 2 plus 4 is 6. So put on 3 here. See, finished. This reaction is 2CH4 plus 3O2 gives out 2CO plus 4H2O. Okay. Now this one. So you see 2 carbons, 4 carbons are there. So here you put on 4. 4 you put. So hydrogen here becomes 12. So here hydrogen is 2. So 1 6 you put here. This is 6. Finished. Now oxygen is here. Here oxygen is 4 plus 6. That is 10 oxygen. So 1 5 you put here. See, this one is the reaction. See, we get 2CH4 plus 3O2 is of 2CO plus 4H2. And here it is 2C2H6 plus 5O2 gives us 4CO plus 6H2O. Okay? See, carbon monoxide gas. This gas formed. It's a very harmful gas, you know. It causes greenhouse effect and global warming. So, due to this, the insufficient supply of O2 is not favorable. In the exam, the question will come: why the insufficient supply of oxygen during the combustion of the alkane is not favorable? So that time you have to tell if the insufficient supply of oxygen during the combustion of the alkane is not favorable because it produces the harmful gas carbon monoxide, which causes global warming or greenhouse effect. Okay. One more time I am putting the question. In the exam it may come why it is not favorable the insufficient supply of oxygen during combustion of alkane. At that time we have to tell that it is not favorable that there is insufficient supply of oxygen during the combustion of the alkane because it produces a harmful gas carbon monoxide which causes greenhouse effect and global warming. Okay, finish this one. Combustion of alkane is finished. The combustion of alkane is finished. Yes, now I am going to teach you a new thing. See friends, now I am going to teach you the slow combustion of the alkane. Now I am going to teach you the slow combustion. Slow combustion. See friends, now I am going to teach you the slow combustion. We finished the combustion part in before this one. So now I am going to teach you the slow combustion. Okay? Slow combustion means what? I am writing one chain, you see that. See first will be alkanes. Here will be freshly prepared oxygen. Here acidified K2CR2O7 and KMnO4. Here will be freshly prepared oxygen. Here catalyst will be K2CR2O7. That is potassium dichromate. This potassium dichromate or KMnO4. Or KMnO4, okay? So you see alkane, freshly prepared oxygen, then here K2CR2O7 is potassium dichromate and KMnO4. So you finished. Now after this, from alkane it will go to alcohol. Alcohol. Finished. Similarly, their condition will be same only. Freshly prepared oxygen and K2CR2O7 or KMnO4. Same reaction. After alcohol, it will become aldehyde. Aldehyde. See, aldehyde. First from alkane it became alcohol. After alcohol it became aldehyde. Okay, it became aldehyde. It became aldehyde. It's alkane, then alcohol, then aldehyde. Okay, finished. aldehyde. After this, from aldehyde it will become after aldehyde it will become carboxylic acid. From aldehyde it will become carboxylic acid. See, carboxylic acid. Here also same oxygen. Here also same freshly prepared oxygen, and they are K2CH2 or KMnO4. So from alkane it became alcohol. After alcohol it became aldehyde. After aldehyde it became carboxylic acid. So after this, again similar condition. This carboxylic acid will react and form CO2 and H2O. See. So alkanes, freshly prepared oxygen, K2Cr2O7 or KMnO4, then it converts into alcohol. For the alcohol also similar condition, freshly prepared oxygen, K2Cr2O7 or KMnO4 converts into aldehyde. And aldehyde, again same condition, converts into carboxylic acid. The carboxylic acid, same condition, converts into CO2 plus H2O. See, I told you the alkane converts into CO2 plus H2O at the last in reaction with the oxygen. Okay? See now here. So in the alkane, let us take one example. Here alkanes. In place of alkane, I will take methane. CH4. See, CH4 I take. Now alcohol means the OH group. So alcohol will convert into CH3OH. See, CH3OH why? This. Here carbon is 1, carbon is 1 only. Here hydrogen is 4. 4 hydrogen, and here freshly prepared oxygen is there. So one hydrogen from here will react with the freshly prepared oxygen and form OH. So CH3OH. Now from alcohol we will go to aldehyde. See, the aldehyde will be HCOH. See, aldehyde will be like this. Sorry. This aldehyde will be HCHO. CHCHO, aldehyde. Aldehyde is HCHO. Aldehyde example is ethanol, or is also called formaldehyde. Okay, like that. Ethanol. It's called formaldehyde or aldehyde. See, here becomes HCHO. After that, this HCHO will react with carboxylic acid. Okay, in carboxylic acid it will form HCHO is already there. One more oxygen is combining with it, so it is becoming HCOOH. Okay, it is becoming HCOOH. So HCOOH. So HCOOH it becomes. After that, CO2 plus H2 is already there. See, from first is alkane, CH4, condition oxygen, freshly prepared oxygen, and potassium dichromate, potassium magnate. KMnO4 is there. Okay, it converts into alcohol, that is CH3OH. Then again similar condition, the alcohol then converts into aldehyde, that is HCHO. Okay, then again the aldehyde, similar condition, converts into carboxylic acid, that is what? It's HCOOH. Okay, that HCOOH converts into CO2 plus H2. It's similar condition to oxygen. Okay, see composition. See friends, aldehyde structure I am showing you. Here aldehyde structure will be what? There is HCH also. So here you have to draw one hydrogen, single bond with carbon, then again hydrogen, and then double bond with oxygen. Then in the aldehyde group. Okay? But HCO, HCO, OCH, OCH. This one is the aldehyde group. Okay? Now the alcohol group will be how? CH3OH. The alcohol group is CH3OH. So, okay. Here one hydrogen, carbon, hydroxide. CH3OH. See, this one is the structure of the alcohol. That is CH3OH. 3 hydrogen, 1 carbon, and hydroxide will be also there. Now alkane structure, to you know, methane structure. One more time I am drawing. See, this one is methane structure. See, this one is the alkane structure. That is methane. So in the alcohol structure, that is this one, this is CH3OH. This one is aldehyde. There is ACOH structure. ACH or ACOH. See, there is a structure. Now carboxylic acid. This one is HCOH. Okay, HCOOH. HCOOH. Okay. CHOOH means what? COOH means acetic acid. Okay. Acid. See, ic acid you have to take. Ic acid. Now you know that CH3COOH, that is called acetic acid. What? The CH3COOH is called acetic acid. That is formed by the reaction of the ethane. That is C2H6. So by reaction of C2H6 and oxygen, acetic acid is formed. That is CH3COOH. The carboxylic acid structure you see. Carboxylic acid structure. Carboxylic acid structure is a little bit confusing. It is not coming in my mind also. Okay, so wait, let me see. See, carboxylic acid structure is not coming in my mind. This is not proper or not, I don't know. So I'm not drawing it. Okay. The slow combustion is finished today. So that's all for now. Today I am finishing till here. That's all for now. Today I am ending here in slow combustion. So today I taught you the combustion and the slow combustion of the alkane. My next class will be the property of the alkanes, that is catalytic oxidation. Thank you.